Hello, everyone. Tell everyone that your favorite uncle is back. And today we'll be looking at part three of the fundamental counting principle. We'll be looking at passwords, we'll be looking at forming committees, all of that has to do with the fundamental counting principle. And this will be our last video in that series. All right, so if you haven't subscribed, please just make sure that you're part of the family. Just hit that subscribe button. And of course, you can get in touch with us. All our details will be on the description of the video. And of course, you can get in touch with us on the socials as well. All right, now let's get into our lesson. Hope you enjoy it. All right, now let's consider an application, right? So since we've learnt about all the rules on fundamental counting principles, we're going to just consider some mixed examples in this case. So the first one, I want us to look at, electing committees, right? So they say to us, we've got a school that wants to elect an SGB executive committee, right, which consists of chairperson, deputy chairperson, and a treasurer, right? They say if the committee consists, so it means that we've got 5 males and 5 females that we can choose from, that we can choose the executive committee from, right? They say determine how many ways the executive committee can be elected if, first of all, there are no restrictions, right? Now, notice when there are no restrictions, I want you to think about it. So I want you to just consider. So let's say this one is for the president or the chairperson rather. So this is for the the chairperson. Let me say chairperson, and then let's say this one is for the deputy. So that's going to be deputy chair. Okay. And then this one is for the treasurer. Okay, so now how many people can we choose from? In this case, we can choose from 10, right? So once we've chosen a chairperson, right, how many more people are left? We can there are now 9 people that we can choose from. So in this case, we've got 9 that we can choose from. And once we've chosen a chairperson and a deputy, so how many people are left that we can choose from? That would be 8 in this case. So it means that the total number in this case of combinations that we can choose from would be 10 times 9 multiplied by 8. Okay, so if we do that, 10 times 9, okay, so that's 10 times 9 times 8, that would give us 720. So it means that if there are no restrictions, there would be 720. But I want you to think about it. In this case, we said, look, what we can do is that we can take the total outcome divided by n minus r being the number of positions that are there, right? I'm sure you remember that when we did that, right? So in this case, what's n? So we've got 10 individuals, right? 10 factorial divided by, in this case, there are 10 people, but we've got only 3 positions that are available. So that would be 10 divided by 10 minus 3, which is 7 in this case. So you would actually get the same number, which is 720. I hope that makes sense, ladies and gents. Right, now, they say, let's determine how many ways the executive committee can be elected, right? How many ways can they be elected? If the vice chairperson must be a female, right? So if the vice chairperson must be female, right, I want you to think about it. So there are 2 possibilities, right? Okay, so let's say we've got our chairperson here, we've got our deputy here, okay, deputy chair, and we've got our treasurer, right? So in this case, I want you to think about it. Okay, so we know for sure that our vice chairperson must be a female. So how many can we choose from? we can choose from 5, right? So remember, that's the number of females that we have, right? So in this case, we can have a chairperson being a male, so the probability of them becoming male, so we can have this one being male and that one obviously would choose from the rest. It really wouldn't matter, right? So in this case, so we know we can look at the possibility where the chairperson, okay, is a male. So if the chairperson is male, so in that case that would be 5. So that would mean that the number of people that we can choose from in terms of the treasurer, that's 8 people that are left, okay, because it doesn't matter whether the chairperson, or rather the treasurer, is male or female, right? So we've got 8 people that we can choose from. Remember, we've taken one as a chairperson, being a male. All right, we've got a female as a vice. So in this case, we've got 8 people that we can choose from, right? Another possibility is that what if we take the chairperson as a female, right? That is still a real possibility. But remember, in this case, if I say the chairperson, okay, so let's take chairperson, let's take deputy chair, and let's take treasurer, right? So if we've got, in this case, our chairperson, or rather, let's start with the deputy chair, right? Definitely, our deputy has to be a chairperson, all right. Our deputy chair has to be a female, but remember, you've already chosen one there, right, in the first outcome. So now I'm looking at the probability of our chairperson being female, right? So that would mean that in this case, we've got how many? We've got 5 females, right, that we can choose from. But now, if we've already selected a female, in that case, remember, this was the probability of a male in this case, all right? This is now probability of it being a female. So we've got 5 we can choose from. Now, how many do we have to choose from in this case? That would mean the number of females would be 4, right? And of course, here, how many do we have left? We've got 8. So the number of possibilities in this case would be, first of all, 5 times 5 times 8, okay, plus 5 times 4 times 8. Okay, so it means you've got 360. Now remember, in this case, remember that our choice was dependent in this case. If we selected a chairperson as a male, that was the possibility. If we chose the chairperson as a female, that was the possibility, and that's why we said or. And remember, once we say or, in this case, we just simply add, and we said the total number would be 360. All right, so I hope that makes sense, ladies and gents. Right, now the last one, they say, well, what if the committee must consist of mixed gender, right, with at most, right? Now note, in this case, once they use the word at most, 2 females, so it means at most means that we can go to 2 and not above that. So we can either have 1 or we can have 2. So you can see that's also a dependent factor there. So let's consider a possibility. Remember, it must be mixed gender, right? So you can have a possibility where you've got, for instance, now 2 females. Okay, so you can have 2 females, all right, and 1 male, and 1 male. Or in this case, you can have 1 female. Remember, they said at most, so that means that 1 would still be acceptable. So 1 female, okay, and 2 males. Okay, so we're going to look at those 2 possibilities, right? Now, let's look at, so we said we're going to have our chairperson, our deputy chair, and our treasurer in this case, right? So if we are considering, right, female, female, male, okay, female, female, and a male there, right? So what are we going to have? So if our chairperson is female, so how many do we have? We've got 5. But now that we've chosen one, we've got 4 that are left to choose from, and that's female. But how many males in this case? Of course, we do have 5 males that we can choose from, right? So that would be 5 times 4 times 5, right? Now we're going to say plus. So remember, in this case, we are saying plus because it's an or, so it's a dependent, right? It's a dependent outcome. The outcome depends on what we choose, right? So in this case, 1 female. So let's consider again, you've got chairperson, you've got deputy chair, and you've got a treasurer, right? So we now said, look, what if we considered a possibility of having female there, right? Having male there and having male there. That's still a mixed one, right? So that would mean in this case you've got, how many females did we have? We've got 5, right? But now males, we've got 5, but once we've chosen a male there, how many do we have left? We've got 4 to choose from. So that would be 5 times 5 times 4. All right, so now you're looking at the total outcome there. 5 times 4, that would become 20. All right, multiply that by 5. That would be 100, and the same is true here. You've got 25 times 4, which is 100. So it means that the total outcome there, or rather the total number of possibilities, are 200. Okay, right. I hope that makes sense in terms of this example, ladies and gents. All right. Right, now let's consider another example where we are now looking at creating passwords. Right, so they say a 6-character password is required to consist of 2 single-digit numbers, right, followed by 2 lowercase letters, okay, followed by 26 uppercase letters, or rather, you see, I'm thinking of the number of letters that we have, by 1 uppercase letter and thereafter by special characters. Okay, so they've got that ampersand, that $, hash, and @ right? So in this case, they say to you, determine the number of possible passwords that can be created if, right, now first of all they say if repetition is allowed. Now ladies and gents, if repetition is allowed, so remember that our password needs to have 6 characters, right? So that would be 1, 2, 3, 4, 5, and 6. Okay, so how many do we have? Remember here they said we need to have 2 single digits, so that would be digit here. Okay, that would be digit over there, and then they said followed by uppercase, by 1 uppercase, followed by 2 lowercase letters. So here we would have letters, okay, and they didn't give us any restrictions, so letter and letter there. And then they said an uppercase letter, so in this case you would have that as, okay, capital letters, and then you also have special characters, which in this case and $. So we've got special characters. Okay, right, let's just call them characters there. Okay, right, now in this case, how many digits do I have? Remember, you've got 0 to 9, so that would be 10 digits, so that would be 10, right? Multiplied by, in this case the repetition is allowed, so you can still choose from the 10 again, right? Multiplied by the number of letters that you have in the alphabet, that's 26. Okay, so in this case, how many letters again? Remember, repetition is allowed, so you can say 26 and then a letter. So you've got 26 again, and then special characters, we've got 4 of them here, so that would be 24. So you can multiply all those out. I'm not too sure what you can find there. So that's 10 times 10 times 26 times 26 times 26 times 4. Okay, so the total number of outcomes is 7 million or 70 million. 70 million 304. No, actually it's 7 million. Let me just write it down properly. That would be 7 million and 30,400. Okay, right, so that's the number of possibilities that you have. Right, now they say to us, if repetition is not allowed. Okay, so again, let's try and draw our boxes. In this case, it's a 6-letter password. We know we've got different possibilities there. So now what we are going to do, remember this would be digit, right? This would be letter, okay, small letter, and this would be capital letters, okay, caps, and then this would be characters, okay. Right, now if repetition is not allowed, so how many digits do you have? You've got 10 that you can start with, right? But now remember, you've used 1 here, so how many can you choose from here? So you've got 9 that you can choose from. And then what about letters? You've got 26 that you can choose from there, right? But now that you've used 1 here, so how many do you have left? You've got 25, okay. Obviously, I'm going to assume that you can't even repeat a capital letter in this case, so that means you've got 24, and of course your characters, that would be 4. So in this case, the total number of possible combinations that you can make would be that number there. Okay, so that would be 10 times 9 times 26 times 25 times 24 multiplied by 4, and that would be 5,616,616,000 actually. Okay, right, I almost said rands. Okay, so you'd see, obviously, when repetition is not allowed, the number of possible outcomes decreases. Right, now the third one, how many combinations can we make if no repetition is allowed and the uppercase letter is a vowel and the number 0 is not allowed? So in that case, I want you to think about it. By the way, I sourced this example from one of the YouTube channels as well. Okay, and I'd like to say a special thanks to them, for having such an incredible example. Okay, right. So in this case, what I am going to do there. So remember, we said in the first one you've got digits. Okay, remember repetition is not allowed. You've got letters. Okay, you've got a letter, but remember now your letters are vowels in this case for your uppercase, and you've got characters. Now let's start with the digits. Of course, how many do we have? We've got 10. Oh, by the way, they said 0 is not allowed. Sorry about that. So in this case, remember, without 0, you've got 9 of them. So you've got 9. Okay, so we're going to start there with 9. Okay, and then we've used 1. So therefore it means for the next one, you've got 8. All right, now for the letters in this case, now they say for the uppercase. So I'm assuming that obviously we're only allowed to use vowels for the uppercase letters. So in this case, it means for these smaller case letters, you're only allowed to use consonants, right? So in this case, I'm going to say, well, that's 26 minus the 5 vowels. So you've got 21, right? Multiplied by now you've used 21 there, so you've got 20 that are left. So multiplied by, in this case, you've got, how many vowels do we have? We've got 5, okay, for your uppercase, and then multiplied by your special characters, which is 4. Okay, right. So I hope, ladies and gents, that makes sense. So that's 9 times 8 times 21 times 20 times 5 times 4. Okay, so you've got 604,800. Now, I hope you're appreciating the fact that, see, every time that you are introducing restrictions, what it does is that it obviously affects the number of possible outcomes that you can possibly have. All right, now let's take another example, and I think we can wrap it up. All right, let's have a look at this example. That would be, I think, ladies and gents, we've tried to really do justice in this section. All right, so let's have a look at this final one. So they say to us a 5-digit PIN code is required to open a device using the following numbers. Okay, so we've got 0, 1, 2, 4, 5, 8, and 9. Okay, they say determine the number of PIN codes that can be created if, right? Now, if repetition is allowed. Now, how many numbers do we have? We've got 1, 2, 3, 4, 5, 6, 7, right? So we've got 7 numbers. So it means if we are going to make a 5-digit PIN code, so we can choose from those 7 numbers, right? Okay, so that would be our PIN code. So how many numbers can we choose from for the first digit of our PIN code? We can choose from the 7 numbers, right? Okay, and again, they said repetition is allowed. So in this case, you can have a PIN code with all the same number, right? So that would be, again, 7 numbers that are available. That would be 7 numbers that are available, 7 numbers available, 7 numbers available, right? So in this case, again, we can use that principle where we say this is 7, this is 7 to the power of 5. Okay, so this is when repetition is allowed, right? Okay, so if you say 7 to the power of 5, 7yx5, I get 16,807. Okay, right. Now, they say if repetition is allowed, okay? So remember, once we allow repetition, in this case, it does affect how we can formulate our numbers, right? So in the first digit, okay, how many do we have? We've got 7 that we can choose from, but now we've used 1, we can't repeat it. So how many do we have? We've got 6 that we can choose from. How many do we have? We've got 5 that we can choose from. We've got 4 that we can choose from. We've got 3 that we can choose from. So that would be the number of possible outcomes. Alternatively, ladies and gents, I'm sure you see this now, right? That you could have said, well, this is 7 factorial divided by, now remember, in this case, you've got 7 digits in total, right? Minus, in this case, the number that you have here. So that would be 7 minus 5. Okay, and in this case, that would give you the number of outcomes that you have. All right, so let's do that quickly. So you've got 7 times 6. Okay, let's try and... Okay, so that's 7 times 6 times 5 times 4 times 3. Okay, I get a number of 2,520. All right, hopefully that's what you get as well. Okay, you can check as well when you use those factorials. Right, now they say to us that the code ends with an odd digit and no repetition is allowed. Okay, so they say it ends with an odd digit. So remember, we've got 5 digits that we can choose from. Now, this is the last digit, and in this case, we know that the last digit has to be odd, right? Now, I want you to please consider how many odd digits do we have, okay? So we've got 1, we've got 5, and we've got 9, okay? So in that case, we've got 3 of those odd digits. So we've got 3 odd digits. But now I want you to think about it. Once you've chosen that odd digit, remember they said repetition is not allowed, right? Now let's go to the other digits, right? So in this case, how many do I have to choose from? Now I've got 6 that I can choose from, right? And then, of course, you've got 5 that you can choose from. You've got 4 that you can choose from. You've got 3 that you can choose from. All right. So that would be the number of possible outcomes that you can have. So that would be 6 times 5 times 4 times 3 times 3. And in this case, that would be 1,080 possible combinations that you can make. All right, ladies and gents, I hope this has been very helpful to you. Hopefully you can now do best when it comes to this. Right, and please remember that you can always visit our website. That's www.mlungisinkosi.co.za. You can see the tabs at the top there. You can get past exam question papers from this website. Okay, all your matric past papers. Of course, we're still going to load some more as well. Also IEB papers as well. You can also just check out courses in this case. So if you want to get a more structured approach to our course lessons, they are all free, right? So say for instance you wanted to go to acids and bases, you just click on that and it will show you all the videos that are on acids and bases, and you can actually watch them sequentially. All right. Yeah. All right, just one last thing. Of course, you can always visit our channel, just to see the most updated lessons. Please always make sure that you are subscribed to the channel. We're trying to get to that 100,000 mark. And thank you for those of you who've been part of the journey. And now we are at over 80,000. Of course, you can always check out our most updated videos, okay, to go and check what our lessons look like. And you can use the playlist feature to try and see the lessons in how we've ordered them sequentially. We've tried to group them into playlists, so you can use that particular feature. And finally, ladies and gents, you can also use the super thanks feature. All right, so if you want to look at it there, you've got your super thanks. You can actually give a monetary gift, just to say thank you to your favorite uncle for the lessons. All right, and I just want to keep it there for today, right? All right, we've reached the end of our lesson. I hope that you really did enjoy that series and that you understood it. Of course, you can still reach us. Please comment, please like our channel, and please, just get that algorithm going so that we can keep growing and making sure that we give value to all of you. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.